Good morning. This is session 3AY of GSE 2021, presented by Dean Harrison, and it's called Lockdown. Please remember 3AY for your feedback at the end of the session. And please show your appreciation for the presenters and all the time that they've taken to put together all these presentations and so on, by giving generously to our charities this year, RNLI and Guide Dogs for the Blind. And
slide for which will be at the end of the presentation.
Yes. Slight technical glitch there. And your generosity may not go unrewarded, as it could give you a ticket. Well, it will give you a ticket into the raffle, for which there are obviously prizes. Okay, so questions, please put them in the chat. You are all muted, so I will at the end of the session give you the ability to unmute yourself to generally chat to Dean or even ask questions about the presentation. So with no further ado, over to Dean.
Okay, well, thank you for turning up for this session. I understand you could have all come on a digital tandem today, but never mind. We're talking about lockdown today, and I don't mean the kind of lockdown that means you can't come to my presentation. I mean lockdown in RACF terms. And I say in RACF terms, we're going to show you how to do it in RACF, but a lot of these processes will also apply to other security tools that are available should you wish to lock down your IZWS environment. And if somebody's not familiar with the term IZWS, it's what used to be TWS, IWS, OPC, whatever you want to call it, but it's now IBM Z Workload Scheduler. So what we're going to look at, I've done a presentation like this before. This is slightly more focused on the RACF side now, rather than just sort of looking at threats and things, but we're going to look briefly at the threats. And then I'm going to go into a little bit more detail than before in how RACF works with IZWS. And then we're going to go through a few little bits to tell you how to keep users in check, getting rid of the dreaded super user that your auditors all hate, and some rough hints on how you can get there in a reasonably painless manner. So, here be dragons. Where are the threats? What are we actually needed to protect against? Anybody that saw, keeps doing that, keeps on super skip. Anybody that's seen my previous presentation will recognize this slide. These are the kind of ways that your ZOS system could be under threat through IWS. Now, I know ZOS itself is fairly difficult to hack, but the one thing you have to remember now is, especially with things like IZWS, we have off mainframe connections to it. So there are all sorts of exploits and things that potentially could be done there that we need to worry about. But equally, if we're not talking about straight hacking, the things you also might need to worry about is basically your employees. Not necessarily anything deliberate, just protecting themselves from doing things that they shouldn't be doing by accident, or the good old avoiding process. I don't want to raise a change for this, I'll just do it kind of thing. And then, of course, you've got grievance attacks where someone's just about to hand in the notice and might plant a little time bomb somewhere, or genuine fraud. I have come across cases where people in the batch admin department have, quite nicely created a new branch of a shop and processed some orders and made some money out of it. So you need to watch what you're doing. There's all sorts of stuff that you need to be able to lock down there. And of course, we mentioned accidents, but also there's the plan refresh, which is useful only in disasters normally. But if you do it by accident, then you've got your own little disaster to deal with. And also you need to think about cross life cycle. So can someone on your test controller exploit super user capability of IZWS to do something to production? Again, either deliberate or by accident. You know, if they bring down some production code to test in test and forget to repoint it at production, will it be able to talk to production? You would hope not. And the big thing as well, you need to think about, when you're designing your security, think about the complexity versus the ease of maintenance, and balancing the business need up with the need to close down the good old super user. Because in some cases, you might have a genuine need to leave things the way they are. So, I have to apologize here. My mouse appears to be double clicking or something. It used to skip in a couple of slides at a time. So there are two parts to the puzzle as far as security is concerned. There's what users can do inside IZWS itself. So can they update the database? Can they update the current plan? Can they run stuff? Things like that. But then there's what the batch jobs can do. And this is probably the riskiest part, because the batch jobs need to be able to update your production systems. So you do have to worry. Along the bottom here, we've got this thing called an elevated attack. You can have somebody that's got access to IZWS that doesn't have access to run jobs in production, but might be able to get IZWS to do something for them that they shouldn't be able to do. And this is the thing that we're going to look at today, how we handle that. And now I click and it doesn't go anywhere. Here we go. So how does RACF work with IZWS? What's the lock and what's the key, and how do we handle all this? Well, first off, there are 3 horror stories on this page as far as security administrators are concerned, certainly as far as auditors are concerned. This, strangely enough, seems to be the most common style of security in IZWS, is that users are either led into IZWS or not by the application resource. So you can either come in and do everything, or come in and look at stuff, or you can't come in at all. And all the batch runs under one user ID. So this means if you've got the ability to update the current plan, you've got the ability to do absolutely anything in your company's batch. There are customers out there that work this way. Personally, I would not recommend it. It is way too loose and up for abuse. So then method 2, IWS has things called fixed resources. So you can at least confine users a little better. So you can let people in to be able to write the scheduling definitions, but not be able to run them. And instead of letting the TWS do absolutely everything, you give it surrogate authority to user IDs that have the access to do what they need to do. Slightly better, but there's still nothing to stop a user putting a user card in their JCL that doesn't apply to them. And because the controller or tracker has got the ability to run surrogate for anything, it will let them. So you can still break out of the bounds of what your job role would allow you to do. So another little super user down here. A little bit more lockdown. You can use exit 1 and it forces putting the user card in the JCL. Now, you can still get around this. I'm not going to say how, in case you don't know, but there are ways to get around this, but it's a lot harder. So you can basically go into here and still try and run jobs under a different user ID if you know how to get around the exit. Oh, hello. Something just flashed up on the screen there. Right. This is the one we recommend, and this is the one I'm going to talk about today. We use sub-resources in IWS, which basically says each user that goes in can only update the type of objects you want them to update, and only stuff that belongs to them. And then it uses this wonderful thing called authority groups. Now, in RACF terms, an authority group is just a user ID that the batch runs under. But the nice thing here is because of ICWS's elevated security status, it doesn't need surrogate access to use authority groups. It just launches the jobs under the user ID that this particular piece of batch is designed to work with. Now, as a user can only update stuff that belongs to them, and they can only use authority groups that belong to them, if they try and sneak an authority group into there that they're not allowed to, RACF stops them. Equally, if they edit the JCL and try to put user equals on the job card, because you don't give ICWS surrogate authority, it also stops them. So far, I've not found a way around this, other than people still doing what they shouldn't do in the scope of their job responsibility. You know, they can still, if it's a payroll developer, they can still do stuff that payroll developers can do. So potentially write programs that do things in production, but you're never going to be able to stop that. That's your quality process that really needs to stop that kind of thing. So we're going to talk today really about using sub-resources and using authority groups to really lock down ICWS. So, complicated table, but I'll try and make it easy now by talking around it. There are all sorts of different elements to ICWS security. And these first three here are what I would call a cascading level of update access. So the first thing is the application class. This is a standard RACF class, and the resource concerned for your controller will be the name of the controller. So you'll do an RDefine for the Apple class for your controller name with a UAC of none. This means nobody can get into your controller at this point. And then you give them permissions to say, for this controller in the application class, I'm going to give this user, well, I actually wouldn't give it to users, but this is just an example, update access to this controller. Now that means at this point, I can do anything in this controller. But then we also have fixed resources. So these now define the different types of things that you can update. So AD are application descriptions, CL calendars, CP current plan. And again, you can start to say which groups and which users have update access to these elements. So if I define the AD resource and I say that DNH doesn't have, has read access to it, then even though I've got update access at the high level, I won't be able to change any application descriptions. Equally, if I've got read access at this level, I can do nothing. There's no amount of rules down here will ever give me update access. It has to cascade from the top down. So for any user to be given update at any level, they must have update at all the levels above it, if that makes sense. So here with the fixed resource, we can close people off to different types of things. So typically your application team would have access maybe to the application descriptions, but not to the current plan. And your operators would have access to the current plan, but not necessarily to the application descriptions, that kind of thing. And then we have the sub-resources. And the sub-resources let you be very, very accurate on what you give people access to. So having said, I've got access to application database here, I might say that my particular user only has access to the payroll group, authority group. At which point I can't create an application with any other group in it. I can't update an application with any other group in it. I can't do anything other than put my own authority group in, which means the only stuff I can create in ICWS is stuff that belongs to and can access my business role. Same with ETT and JS. There's all of these things. You'll have to go look in the manual for all of them because there are so many different sub-resources you can use. There are three main ones that I tend to recommend. There's protect applications by authority group, protect JCL by authority group, and protect the current plan by authority group. After that, everything's a bonus. They're the main ones that you'll use. And again, to be able to update a particular application, I still need update access to the application database and update access to the controller itself. And then there are two extra categories on here. These aren't so much cascaded, they are a little bit. But these are new. I think they came in around 9.3. You can actually define which commands users can issue on the panels, because up until 9.3, if you gave someone update access to the current plan, that meant they could add new workload, delete workload, modify workload, do all sorts of things. Whereas you might want to say, well, I only want this person to be able to restart a job, or I don't want this person to be able to delete anything from the plan. And these commands basically will restrict the kind of actions that you can do. But to do that, you know, to delete something from the current plan, you still need update access to the current plan, and you still need update access to the application class as well. And then there are also one or two what I would call global actions that you can lock down with this. And the big one here is the current plan refresh. Again, that's the, if you take anything out of this presentation, it's locked down access to the current plan refresh. You don't want people doing that by accident. One other thing to notice here is that the top level of security is defined by using an already established IBM RecF class called the Apple class. But all of these here are part of a special ICWS class. There's a default one created for you called IBM OPC, or you can define your own. And in fact, if you want to have more than one controller on your system and give them different security, then you will have to to create your own. Come on, there we go. So basically, what we just mentioned there are two different classes involved in securing your system. There's the controller, what I call the controller class, and the application class. The controller class, you might want to create something in the class descriptor table. Here's a rough example of creating something in the class descriptor table. This bit here, pay special attention to, because this says what kind of characters you can have in the resource names. So if you don't put national or special characters in here, then your users, regardless of what the manual says for ICWS, will not be able to create applications with things like @ or hash or whatever in there defined in the security scope. Perhaps to the end of the name they'll be fine, but not, you wouldn't be able to define any rules with those values in. So this is what the first character must be. It must be either an alpha or a national, and the other characters are alphanumeric, national, special, etc. This, I have to say, has not been a RecF person. I don't understand exactly what this is, but you have to have one, and it ought to be unique. And there's a free utility you can download called listcdt that will let you know which POSIT numbers are free. Maybe we'll get a comment from one of the RecF people on the call later to say exactly what that is. And the one thing to notice here is this is the class name of our specific ICWS controller class, and we put the hash sign or the pound sign, depending which side of the pond you're on, at the front here. IBM recommends that because by doing that, you guarantee they won't come up with some new class, supplied class called that in future. Whereas the application class doesn't have the hash or pound sign at the front and can't, because that must match your controller name. This you can actually call whatever you like, and you tie it to the controller elsewhere. One other thing to notice about ICWS security, 3 levels of security: none, read, and update. None means not that you can't read it, but you can't see it. So if you're browsing things in your database and you have default access of none, and you don't have a rule to give you read access to things beginning with AA, they won't appear in your list. It can be quite strange to get used to at first, that some people can see things in the database and others can't. Useful for co-hosting, but also confusing if you're not aware it's going on. Read and update are fairly self-explanatory. But then I mentioned that you can call that class whatever you like, but you tie it to your controller with this statement, the auth-def statement. It lives in your controller configuration palm, so with your OPC ops and all the rest of that. And this line here ties the controller to the RACF class. Then here we've got a line that defines some little command resources, command groups. So here we've said manual hold, manual release, not and unnot are one group of commands, and attempt, restart and clean up, job restart, fast path cleanup, fast path job restart, and fast simple restart. No, that's simple job restart, a fast path restart. So you can start to say different people can have access to these groups of commands. And then sub resources, these are the things that we're turning on sub resource control for. I'll come into a little bit more of that in a moment. List logging. This defaults to all. Do not let it default to all. I mentioned on the previous screen, if you get access of none, then if somebody does a list of everything in the database and they don't have access to a lot of elements because they've got access of none, then everyone that they can't see, they get an ICH 408i message on the console to tell them they've attempted to look at that, can't see it. So don't let that default to all, you won't like the result. Personally, if you are using this option, maybe for debugging to see whether people are being restricted, just use list logging first, and that will show you if you have a anything that's been inhibited by a read access and none. And I've just been told that if any of you classes share the same POSIT, when you perform things like a refresh, all the classes are affected by the same class action. Okay, so probably best to keep them separate, but maybe if I've understood that correct, might be useful for keeping your controllers under the same POSIT. I don't know. I'll see if Jamie replies to that. Oh, agreed. Yes. Okay. And it stopped again. Come on, there we go. Okay, so fixed resources. We mentioned there were 3 levels: the application class, the fixed resources, and the sub resources. Fixed resources, if you don't build it, anyone can come. If there is no protection on the AD fixed resource, that means anybody with update access to the controller can update the database. So defining a particular resource inside RACF is like creating the lock. So here we do an rdefine with our user class, our controller class, for the AD, and we give it a UAC of none. So nobody gets in without a permit. And then we let them in with a permit, or you let in with a permit or a permit, whichever way you want to pronounce it. So we permit this ID, and oh, there we go, it's off again. Oh, come on. We permit this ID update access to the controller class that we do it. So this means this person, but it isn't a person here. This is what I was about to say earlier. I wouldn't recommend giving a user access to anything in ICWS. Use a group, and we'll talk about groups later. But here, this is the scheduling team. So we say the scheduling team has update access to the application database. And at this stage, this means they could update anything in the application database because we've not gone any further in the lockdown. But then we have sub resources, which restrict the access even further by name. So first off, you turn sub-resources on in the auth-def. So the auth-def statement says which sub-resources you are protecting under. So here we are protecting under ad.ad_name and ad.group. The first thing I will say, which confuses me and confuses everybody, is that this is what they're called in the auth-def statement, but in the actual rules, ad.ad_name is ADA, ad.ad_group is ADG. Why they're different, I'm not 100% sure. I guess two different people designed different parts of the product here. But essentially, there's a whole list of these in the manual, in the configuration, customization and tuning manual. There's a whole section on security. There's a list of them which lists their big names and their little names. And the little names are the ones that are used in the rules, and the big names are the ones that are used in the sub-resource statement. And basically what this is saying is we're going to protect every application based on the contents of its name and the contents of the authority group somebody fills in. So you might define them like this. You might say, okay, for name, we're going to give a high level access to anything, and we're going to give some more low level ones to say access by any that begin with AA and access anything that begins with BB. For authority group, I advise a slightly different method of using this here. Is I would say never use a generic rule for authority group, so that the only authority groups you give people access to are fully named, fully fledged, clearly defined things. That way, if somebody creates a new user ID, it doesn't automatically come into use inside IZWS if you'd, for example, done AA*. So I would say only explicitly grant access to each authority group individually. This gives you a lot more control over which batch user IDs can be run using IZWS. Okay, so that's how you would define them, and then you let them in like this. So for example, the asterisk rule, we let the scheduling team in, and the AA rule, we let the scheduling team in and the AA application team in. The BB rule, we let the scheduling team in and we let the BB application team in. Now that might seem a bit odd if you don't know RACF, that here we've got access to everything. Why do we need to give access to these individual ones as well? So why does WA Shed need to be on here, here, and here? And that's because the way RACF works is it finds the most specific rule to the thing that you're trying to access and gives the permission based on that. So if I had an application beginning with AA, it would find this resource and look who's got permission to that. It ignores any other permission other than the best match it finds. And then here you see we've got the permissions for the user IDs. So we let the scheduling team have access to both of these two user IDs, but only the AA application team can use this application authority group, and the BB can use this authority group. The other thing to notice about sub-resources is you must also make sure the fixed resource of the same name is defined. So if we've got ad.ad_name, you must have also defined the AD fixed resource, and everybody that you give update access to here must have update access to the fixed resource. Okay, we've also, this was again new stuff that came in at 9.3, allows you to refine access to the current plan. So again, if you've got update access to the current plan, you can do anything. You can add new work to the plan, you can delete work, you can modify work, change dependencies, restart jobs, anything you like. Now we've added some new levels of security. So you can say, well, I've got update access to the plan, but I can not add new work, but I can modify existing work and not delete new work. We can protect these three high-level actions to say whether I can add, modify, or delete stuff on the plan. And then if you know IZWS, it works at two levels, occurrence level and operation level. And so we can define those same actions at operation level. So you may be able to modify an application, an occurrence on the plan, but can you add operations within it, modify operations within it, or delete operations within it? If you don't provide this level of access, it inherits this level. So if you only create these three resources, then the same people that can add occurrences can add operations to occurrences. The same people that can modify, and the same people that can delete occurrences can delete operations from occurrences. And then there's a couple of others that one will say, can I change dependencies? So can I change them, delete them, add new ones? That's just a one single action you can protect. And can I change the status? So this will basically say whether this person can restart a job or complete it or things like that. So this is new stuff that came in along 9.3. Again, must be added to sub-resources, and they must have the resources defined in RACF, but these are not content specific. So this is whether I can add anything, and the underlying sub-resources decide whether it's things that you've got access to. So if you could only do things in the current plan with an authority group AAT user, then you can only add things with AAT user and modify things with AAT user and so on. These things themselves can't give you that level of granularity in the command. And then also again came in around 9.3, we've got the ability to define blocks of commands. And we saw earlier in the auth-def statement, you define your little command groups. You can have up to 9. I've not seen anybody do more than 2 or 3 of these. And you normally group them into logical chunks. So these are being able to hold, release, NOP and unnop. These are the things based around restart. You must make sure that these sub-resources are on in the auth-def as well. So you need cp.command1 and cp.command2 go into your sub-resource statement. So that's kind of useful. Also, this is something, it's not actually a separate command, but it does allow you to do something you've not been able to do before. The JS file is a file that contains runtime copies of the JCL. And if you've got update access to the JS file, you can change the JCL that's about to run. Now, in some places, we've got, they don't want their operators to be able to change the JCL. They only want the application teams to be able to do things like that. But one IZWS feature here is if there's something in the JS file, it won't go and read back from the library again if you try and restart the job. So what we can do here is we can say, well, operators can update the JS file, but if we don't give them access to the J command, they can't actually edit the JCL. But what they can do is delete the JCL and let IZWS then pick the JCL up from the job library again. Even though physically it lets them go into the JCL and delete all the lines, when they press PF3, if they've got rid of all the lines and they've got update access to DJ, it'll let that happen. If they've not deleted all the lines, but they've changed something and they've not got access to J, it won't let it happen. So it's a very clever distinction that allows your operators to still clear JCL out without being able to change it, if that's what your site policy wants to do. Trying to change slide. Here we go. Okay. So RACF scope. What does RACF actually control? Well, the nice answer to this is pretty much everything inside IZWS itself. It's all the logical stuff inside. So any ISBF dialog user, the RACF rules control their access. If they come in through the dynamic workload console, which is our web front end, the RACF rules define what they've got access to. Program interface, yeah, guess what? It controls access to that. Same with WAPL, OCL, or other sort of API type processing languages. Basically, anything that comes into IZWS through a product interface of some description, these rules are what come into play. What it does not apply to are the IZWS datasets themselves. The datasets are protected by normal dataset rules, and you can actually be in the bizarre situation where a user can update stuff inside IZWS but can't update the IZWS datasets. But that's great because you wouldn't want users going outside of the product to update the datasets correct themselves. One thing to notice, a byproduct of the user access of none is if you're using some programmatic feature like WAPL or PIF, OCL, REST API, etc., and you do a list for a specific thing in the database or the plan, and you don't have at least read access to that object, it will give you return code 4, which is exactly the same as if that item didn't exist. I get many people coming to me and saying, PIF's not working. I'm running this job and it's giving me return code 4, but when I look in the panels, I can see it. And the first question I ask is, are you running the batch job under the same user ID as the ones that you're looking through the panels? And usually they're not. So this is where your list logging first comes in, is if you're unsure what's going off here, turn list logging first on, and when you run one of these jobs, you will get a single ICH 408i to show you that one of the items you've attempted to list you didn't see because you've got a rule in the way. And it tells you which rule's in the way as well, rather helpful. Oh, running a bit behind. Here we go. So how does it decide access? Quite simply, it finds the most accurate rule. So this is where we went back to earlier and said, if you've got an asterisk and more specific ones, it will match to the more specific rule. It doesn't matter if the user has global access to something, it's what on the most specific rule that counts. The other thing is it looks first at sub-resources, then the fixed resource, and then the application rule, and it will take the lowest access. So if you've got read access at the application rule level, you haven't got any, you can't do update to anything, no matter what the higher rules say. Multiple sub-resources. So if you're protecting by application name and authority group, it will again take the lowest level of access. So if it's okay for you to create something by a certain name, but the authority group you're trying to create you don't have access to, it will not let you update that object. And the same goes as if you want to rename an object. If you want to rename an object, you must have update access to the old name and the new name. So these are things to think about when you're trying to update something based on your RACF rules. Authority group, I've kind of mentioned this. In simple terms, it's the user under which the batch job runs, and it only gets used when exit 1 is implemented. I'll come on to that. And it applies to all jobs in an application. There is a new operation user field that you can protect with RACF as well, but you have to write your own exit for that. The authority group field is well protected. It's only permitted users can put it in an application, and only permitted users can submit it or restart things with that particular authority group in. And you cannot change it in the current plan. Once it's in the current plan, it's locked to that. So this makes it virtually impossible for somebody to get an occurrence to do something it wasn't intended to do. So a payroll occurrence can only do payroll stuff. A warehouse occurrence can only do stuff relevant to warehouses. There is, as far as I can see, no way around this unless you happen to be a RACF administrator. IZWS does not need, not have or need surrogate access to these IDs. That means a user can't sneak around it by putting user equals in the JCL. And each job is locked to the authority group in the definition. Like I say, no way around it. This is why I call it lockdown. So how are we going to manage the population? Well, think about groups and roles. And typically these are the groups and roles that you want to be thinking about. You want to think about your operators, your administrators and scheduling teams. In some places, this is the same group of people. In others, these are the people that set the new workstations up and add new periods and things. and these are the people that provide the workload. And then you might want to like developers in there to create their own stuff and do their own testing in test, but they're going to have what I would call filtered access. This is where the sub resources come in. So you'll have one of these groups for each application business team. Don't forget batch. Batch talks to database and plans as well. So make sure you have a batch class for all your high level workload, so thing that's doing housekeeping on the database or backing things up, or your change management stuff that's moving stuff between environments. Make sure you want one for that. But you also want business batch, which, like the developers, is filtered based on what the application can do. So again, payroll batch would only want to be able to do things like change resources that belong to payroll. So these are the kind of things that you want to do. Make sure that you have rules for these for all stages. So even though you may have two controllers, the group will be in, will have rules defined for the test and prod. So for your developers, for test, they'll have update access to the application descriptions and probably update access to the current plan. For production, they'll probably only have read access to everything. And you can decide this at a group level. One thing I would say is also create some special emergency groups for each controller. You create one that can do everything in the database, one that can do everything in the plan, and one that can do absolutely everything, excuse me, including the famous refresh function. And you never give people access to this on a permanent basis, only connect users into it temporarily. That way, if you find yourself in a situation where maybe your big plan of things hasn't quite worked, you can get somebody around it in the short term by an emergency change control process to give them access to this group and get the things done. Then remove them afterwards and look at refining the rules if you need to on a permanent basis. Decide what to protect. We've seen the auth-def thing before. There's lots of things you can protect on. One thing I would advise is RACF security is not naming convention enforcement. You might think it is, but think about what you need to lock down to stop people doing what you don't want them to do. Now, you might at a high level want to do things by name. Just bear in mind that the more things you protect on, the more rules you will generate. So you will have to potentially think about your RACF database size. I was on a project once where we got ready for go live and somebody looked at the amount of rules and realized they've got to resize the RACF database before they could go live. So think very carefully. This is what I would call the bare minimum. Protect on the authority group. So users can call things what they like. You should have quality control processes that say, well, this can't go into production with that name. But they can only do things for their authority group. That's the bare minimum for security, protecting on authority groups. Come on, there we go. And of course, not forgetting accidents. The plan refresh function, 9.5, should never really be used in production. Try everything else first. It is a function of last resort. Use of it can be catastrophic. So I would say that be sure any team that's given access to this function fully understands the consequence of the use of this function and knows how to get around it, because there is a way to get around it. You restart with current plan new, and it'll go back to the last current plan. But protecting against the function is fairly easy. You do an rdefine hash indc for the refresh function, user access none. And here, this is my indc all group. So this would be my emergency group that I would give somebody access to in the case of an emergency. And I think if you need the refresh command, it would class as an emergency. So super user, how do you eliminate the super user? Well, keep it simple. Once you've got your authority groups in place, and those authority groups can only do what that particular business thing does, what you can do is assign an ID to the tracker and the controller that has very limited access. So only enough to do the job of being a controller or a tracker, which is probably update access to all of its data sets and maybe update access to operator commands and a few things like that. And give no surrogate access to any other IDs. That makes it impossible for anybody to sneak access in by putting user equals in the JCL. So that's the first way of getting rid of the super user. The next part is turn on the authority group feature of exit 1. We have a sample exit that if you uncomment this line here, this third line here, it will apply whatever's in authority group to be the user ID that the job runs under. All you need to do, uncomment that line, compile and link the exit, and turn the exit on in the control palm. So your exit statement would need to turn exit 1 on. That's it. Well, rebounce the controller. So how do we get there? How do you migrate to a new RACF policy? Oh, come on. There we go. So there's a checklist. First things I would say is make sure all your authority groups are set before controlling them with RACF. What I mean by that is get them all filled in the database if you can. There is another way to do this. I'll mention it in a moment. Make sure all the data conforms to any values being enforced, because if you've got rules for AA, AB, AA, BB, CC, and someone's got something in there that begins AD, and you don't have a rule for AD, and you don't have an AD asterisk rule, then nobody's going to be able to do anything with that application. So make sure that everything is sorted, named properly before you turn all this security on, because filtered users won't be able to see objects that don't conform. You'll have to get global users to be able to fix them for them. And also, I would say, before applying a set of new rules, check how many instances of that type of object exist in the database, and then check again after activating the rules. And that'll give you a very quick clue that something's been hidden, so you've got some rules missing somewhere along the line. So they're the kind of things you need to be aware of before you start turning all this on. Now, authority group. If you've not got any authority group set at present, what you might want to do is gradually switch over to using authority group. Now, I mentioned earlier not to create an asterisk authority group field, because that would allow people to create authority groups that aren't on the list. But there's a nice little trick you can do, is if you create a generic authority group with asterisk, and then one for every letter of the alphabet that an authority group may begin with a UAC of none, and you let people have permission to the asterisk rule, but not to these, then what happens is people can create authority groups by the explicit names that you've already created rules for, and they can create authority groups that are blank, but they can't create anything beginning with A, B, C, D, E, F, G, etc. that doesn't have a specific rule for it. So it allows you for a period of time to allow a blank authority group to be changed to a real authority group. Because if you didn't have access to blank, you couldn't change it to something real. So this little trick will give you a rollout period. When you've done, then you remove these permissions and you remove these resources. And then the only time anybody creates a new application, it must have a recognized authority group in it. So how would you go about it? What's your basic sequence of events? Well, create the new rules for your controller under a new class and populate all the groups. You can change the auth-def then to point at this new controller class, bounce your controller, and you go live. The nice thing is, because this is a new class, you can change the auth-def back to what it was and bounce the controller to back it out. So if you put it in and you find, oh, hey, no, things aren't correct, then you can very quickly go back to the old way of working, as long as your controller class is a new class that you weren't using before. There is one slight downside to that, and that the application class you can't bounce in and out of because it's the name of the controller. but the application class is the highest level of access and would rarely change. So most people that have got update access somewhere in the controller would have it both before and after this change. You can then populate the definitions with authority group and remove the temporary ADG resources when done. So that was stuff on the previous slide. And finally, you want to create your user IDs for each of the authority group. If you haven't already done it, in some cases, you may already have these as user IDs that you converting from user equals in the JCL. You could test them individually by giving surrogate to the tracker and controller temporarily to say, okay, if this job ran under this user ID, would it work? And when you're confident that all of your authority groups have the relevant level of access to do what it is that you would want them to do, you can then turn on exit 1 and switch the tracker to the new restricted ID. And again, if you find that that's gone wrong, you can reverse that, turning off exit 1 and going back to the normal godlike ID that your tracker controller has. So that's kind of a very rough plan for how you get there. There's all sorts of auditing tools and things out there that will help you along the way. I'm not here to sell auditing tools, but there's all sorts of different ways you can find what access your batch jobs really need and hone them down and down so that eventually each authority group only has the absolute bare minimum for what that particular piece of business needs to do. The only people that can write stuff to do with that authority group are the developers whose business it is to write that stuff. The only people that can submit that stuff, again, are the people that you have decided have got access to the current plan for that authority group. So it is as locked down as you can do. I was about to say any questions, but Bella decided she's telling us somebody's walked past the house. Hang on a minute, just got a little note in. Yeah, there we go. Yeah, and I've got a comment here that somebody with exactly the same opinion as me is have a one batch user ID per application. And yeah, say a lot of sites won't go there. I think over the next few years, a lot more sites will be thinking more about going there because they're finding the one thing we are finding that's driving this change. We've got a customer in the US that's actually going through the pain of going from one single super user to individual users. And the thing that's driving them there is wanting to move to DevOps. And as soon as you open a scheduler up to multiple users with multiple roles to be able to do things, then that's when you really need this lockdown. Otherwise, you are wide open for abuse, either accidentally or on purpose. But yeah, we're definitely in agreement here. One user ID per business. And in fact, this particular user has one or two going for a couple of authority groups for some parts of the business. So there's a basic authority group that can run the batch. And then there are some special authority groups that can do things like stop and start bits of the infrastructure for that application. So some are going even further. But that's kind of it. That's how you lock everything down. You know, if you ever wanted an illustration of a guard dog to keep everything out of your batch, we had one there very briefly at the end of the presentation. But yeah, any questions?
Okay, so you have the ability to unmute yourself and ask any questions you like, or you can still put them in the chat if you're a little shy. I will say that I have experienced this in organizations where the only people who could update the scheduler were a very small scheduling team. And at that point, you allow a trust level. But the second you decentralize your scheduling, you're in trouble.
and this seems to be the big driver at the moment. The drive towards DevOps and decentralization is most definitely making people think, hang on a minute, what does that really mean to the safety of my business? And interestingly, most of the time, they're actually thinking more about safety by incompetence or accident rather than safety by fraudulent actions. But whatever your motivation, getting to a lockdown like this, I think, is a good place to be in the long run. You can be sure that things won't be able to do what they should be able to do.
And you can keep it simple.
You can, like I say, you can protect on all sorts of parts of the names of the objects, but to be absolutely fair, from a security point of view, do you really care if people are calling things without decent names? That's more of an operational point of view. If you have a process that you must pass quality rules to get your stuff into production, then you don't need RACF rules to protect that, because if they haven't got update access to production, the quality process won't promote anything that doesn't meet your naming standards. So, you know, do you create all these security rules to stop people doing things they shouldn't, or just teach them? Teach them and enforce them.
Hi, Dean, it's Jamie here.
Hello.
Hello. So I'm interested to know, I don't see, talking about sort of all different securities or, you know, controls you can have, I don't see many people taking a vested interest from an audit standpoint, you know, like looking at the controls that have been implemented and sort of validating if they're effective for the organization. I don't know if you have got different experiences to that.
I'm starting to see it.
Right.
And I say this is where when this particular company in the US wanted to start to roll out access, the auditor started to get a little bit nervous and said, well, how are we going to ensure that all these things are being conformed to? So they've got a third-party team in doing their security administration with a whole set of auditing tools. They've been asking me to create an environment for them where the change control process is the only thing that updates production. They are, in fact, rather bravely wanting to go to a situation where their scheduling team cannot update the database in production under normal circumstances. In the long run, they want only things to go into production through a batch change process. So there are some going there. But yeah, there's been this, as Anna said, this circle of trust scenario for many, many years. And I think basically the auditors have been browbeaten by the business to say, these people are trustworthy, this is the way it works, there is no other way to do it. Well, there is another way to do it. And this presentation gives you some clues on how to get there, I would say. But yeah, it's one of those strange things that's actually, from a security point of view, quite a nightmare, but has for a long time gotten a free pass around audit, I think. And I think that may be changing. I think that the thing that maybe made most differences to people was a recent meltdown of batch for a certain financial institution north of the border. And suddenly a lot of companies became very aware that there was this tool out there that had access to their entire business, and they started to get interested in things happening in it. And we're starting to see some of that bleed through with a lot more interesting controls and security and all sorts of things.
I'm very glad to hear it.
but not as much as you might imagine. There are some very big institutions out there that I think if customers knew that they were doing certain things, maybe would go somewhere else.
Yeah.
Do we have any other questions or comments or chat items? It's fine. But I could leave the session open for another 15 minutes if anybody wants to just discuss anything with Dean. But for those of you that want to leave, this session is 3AY. Please fill in your feedback for that. And then
That's Bella. That's Bella's feedback.
and then on the question about the length of the presentation, 5 is the correct answer. Just don't go down there going 99999. I know that's you know, something that people do. It's very
Surely
inviting
not.
to do that.
Surely not.
But actually 9 just means the session was way too long. 5 would be the optimum answer to that one. So make sure you are reading the feedback questions correctly. And to show your appreciation to Dean and to all the other presentation givers that have taken time out of their normal schedules to create these sessions and to give them. Please show your appreciation by donating to the RNLI and the Guide Dogs for the Blind, and you know, give yourself a chance in the raffle. Okay, I will just lead the appreciation now to Dean, because I still haven't worked out how to make the clapping hands come up on the screen, so I shall.
There you go.
You know, it's technology. I'm no
It's
good.
technology. What do we know about technology? Exactly. And of course, I did manage to get the presentation in just in time. So here's the charity slide and the last one.
Yeah. Also, do think about becoming members of GSE. If your company isn't a member of GSE, there are now actually individual memberships available. So, you know, if you want to join GSE as an individual, that's actually quite good. But, you know, you should promote it to your company. Your company may already be members, you just don't know that. So it's worth going and asking your system programmer area, who are normally the holders of the membership, whether they are members, because there are advantages. They have free places to the face-to-face meetings and so on. So you may find that nice. If you don't know, or they don't know, you can always ask us, and we can check on the membership roll to see if the company is already a member. But as I said, there are advantages to being a member. Okay, so that's me going to shut up now. But if you have any questions or you want to chat to Dean, the floor is yours.
I think you'll find as well that when you first look at this presentation, there's a lot to take in. When you start to look at doing it yourself, if you have any more questions, come back to me. dean.harrison@hcl.com, not hard to find. And of course, I'm available for services, so so you can employ me to help you do this.
Other service providers are available.
Other service, yes. Well, I mean, Anna's done this as well, so you can ask Anna. And then for the bits she don't know, she'll ask me.
And vice versa.
Yeah. But yeah, it's one of those things that you'll find you understand more of it as you try it. There's
Yeah.
no substitute for doing. I can show and you can do. Right.
Well, okay, if nobody else wants to make any comments or in any other way discuss security and IZWS, then I will close the session.
Thanks, everybody. Bye-bye.
Thanks. Bye.
Bye.